Again, are you getting sick of it yet? I'm going to appeal to a graphical method to understand it, and then I'm going to have to pull out some algebra to know what the exact value is. But maybe you'll be able to see what's going on. Okay? Now, the log graph. What does a log graph look like? As it's coincidental, it's the inverse, it's the opposite of the exponential graph. They're sort of like, you know, my evil twin type thing. Okay? So what does it look like? It looks like that, but reflected. So here's the shape I'm going to get. You'll notice I'm only drawing the positive x-axis, just like I only drew the positive y-axis over there, and there's my log curve. Okay, so it's reflected across y equals x. Okay? So here's my x equals 0 asymptote, because sure enough, I'm approaching that. I can never get there. This is my log base 2 of x axis. Okay. Now, just like I had a y-intercept of 1 here, I have an x-intercept of 1 here. So that's what it looks like. Okay. I want to know when this thing is less than 3. When is it less than 3? Okay. So looking at my scale, I'm not going to be able to go up that far. Let's put 3 here. Okay, let's put 3 there. So that's going to correspond to some point over here, and it's not inclusive. It's not inclusive. And then you can see from here, all the way over to here, I satisfy the inequality. Does that make sense? So I just need to work out, well, what is that point, right? So how do we do this? To work out a point, I work out the equivalent equation to this, right? Equivalent equation. So that's log base 2 of x is equal to 3. And that will find me a point, right? So that's what I've got. And all I need to do is rearrange this log equation in terms of indices, right? So the bases stay the same. 2 to the power of, the subject before is the power now. And x will become the new subject. So x, of course, is 8 over there. And so now I have my boundaries, right? I don't go past here, just like the exponential doesn't go past here, right? So I have to be greater than 0, and then I have to be less than 8. And there's my answer. Okay? Make sense? Because, by definition, 2 things. Number 1, anything to the power of 0, anything to the power of 0 is 1 for this. And therefore, by implication, what's the log law that corresponds to this index law? Log base A. If you raise anything and you want to know what power gives you 1, that will always be 0. A to the power of 0 is 1, right? And 1 is your x. Does that make sense? So in this case, it's 2.